This is a Motorola 688C11 D0CP2. It's a descendant of the original Motorola 6800 microprocessor and possibly the last version to be made in a classic DIP dual inline package. And I have a few of them. Many years ago, the Goodwill computer store in Austin, back when it was still cool, would sometimes get random electronics junk and put it out for sale. One day they had a bunch of some kind of controller boards that turned out to be a traffic light controller. Most had socketed 68HC11 chips on them, and a few had the PLCC version instead. I bought them all. Fast forward to now in 2024. At this year's Vintage Computer Festival Southwest in Dallas, I bought a 68HC11 evaluation board that needed some minor repairs. A capacitor was broken, its EEPROM was blank. I reprogrammed the EEPROM with a monitor program. I noticed that one of the features of the monitor was an XBoot command, which would blindly spit bytes out of serial port to a 68HC11 chip that had been configured in bootloader mode. It would load that into RAM and execute it. In the case of the D0 version, it has 192 bytes of RAM at hex address 40. But when I wired up one of the 68HC11 chips on a breadboard, I made one small mistake. I put the address and data pins of the chip toward the edge of the breadboard rather than the middle. So I'm going to have to do it all over again. Since I'm starting all over again anyhow, I might as well fix up my breadboard. I built a nice little box for it, but the old breadboard has some bad spots on it. Last month I picked this up at a Hamfest, so I'm going to use it to rebuild my bigger one. I didn't expect I'd be rebuilding a breadboard. I didn't even think of it until a couple of hours before, but it's nice to have it fully working now. I've decided that a plain crystal is too much trouble as it keeps getting knocked over, so I'm going to use a crystal oscillator instead. I have a bunch of 16 megahertz ones, so I'll use the 74LS74 chip to divide it by 2. And now to test that the oscillator works. Apply power and check that 16 megahertz is coming out of the can. And that 8 megahertz is coming out of the output of the 74L74. And we have 8 megahertz. So good, the oscillator is now complete. I've found a power switch and added it. Now to place the big chip with pin 1 along the top edge of the breadboard, so that the address lines will all be along the top edge. Then a resistor pack for various inputs. Now for some wiring. And add a reset switch. I added a little 3.3K resistor here because that's the serial input from whatever's loading the data in, and if this is powered off, some of that current will go through the chip, I guess through the protection diodes, and it will cause other inputs to do things, and that's not a good thing. So that limits the current for it. And now to try starting it up. I have my 68HC11 evaluation board set up with a small program ready to send. When the target is configured with the Mod A and Mod B inputs grounded, upon reset it waits for bootloader input, which is stored in the on-chip RAM. In the case of the 68HC11D3, it is waiting for 192 bytes. The xboot command blindly spits a bunch of bytes at it, and when it is done, the bootloader tries to run it. And there it goes. And now for fun, let's try running a version of the same program on the evaluation board. So what's next? The next thing I plan to do is have it start up from an EEPROM.